So now that we know about the contextual environment, we can understand exactly what a procedure is and how it is stored in memory. In fact, a procedure is a value, a data structure, a value stored in memory, just like any other data item. Now, the procedure name, the identifier which refers to the procedure, is just a reference to the value. The same way like when we do n equals 42, the n is just a reference to the integer value 42. So let me show this a little bit more detail. Let me declare here a procedure, inc x, y is equal to x plus a. Notice that inc has a contextual environment. So this procedure declaration is actually declaring a value. In fact, in the same way that a here is bound to 1, well, inc is bound to the procedure value. So let me show just one little detail before we go on. If I browse a, then what do I get? I get 1. If I browse inc, what do I get? I get the procedure here. Now the browser doesn't know how to display the code of a procedure, so it displays the procedure as p/2. Okay, another way to write this is as follows. Exactly the same way as we say a is equal to 1, we can say inc is equal to some value. Okay, so what is this value? Well, it has the following syntax. You can write it as follows. It looks very similar to a procedure declaration. In fact, it's identical to a procedure declaration, except that the identifier that represents the procedure name is replaced by this funny dollar token here. And so this here is the procedure value is bound to inc. So why do we replace this, the identifier inc, by another token? Well, we could just remove inc completely. Since we don't have actually the identifier in this value, we just have the value. But that would be weird because that would put x in the place of the procedure name. It would be confusing. So if we put a placeholder here saying that the procedure has no name, it's just a pure value. And then we can bind it. And so this instruction has exactly the same effect as before. So let me bring in a diagram now to explain this in a little bit more detail. So here we have a program which defines a procedure, inc, with 2 arguments and with a contextual environment containing a. Now, in the kernel language, this is in fact, the inc procedure declaration is in fact the binding of a value to the identifier inc, the purple inc here, which is defined to a proc $xy, y equal x plus a end. And the a also is an identifier bound to 1. And the environment here, the purple environment, corresponds to what's happening when the program executes, and it will give you the references and memory of a and inc. Notice the actual procedure here is what? Make it a little bit bigger. The procedure in memory here consists of 2 parts. It has the actual declaration, proc end with all the code in between. Notice it's a value, it has no identifier, there's a $sign, and it has the contextual environment, which in this case is a. So the procedure value in memory then has 2 parts. And this particular value is then bound to the variable inc, little inc, and you can do anything you want with it. You can pass it as argument, you can get it as a result, you can put it in data structures, and this is the basis of some very powerful programming techniques.